Now let's take a look at how to work with processing. We're going to use processing to receive some information from Arduino. As always, the processing reference page is very helpful. What I've done is I've gone to the serial event function and this wonderful example right here by Tom Igo. I hope I pronounced his name correctly. We're just going to copy paste this into processing. And so I've got a blank sketch here in processing. Right. And all right. Let me make the text a little bigger here for you. All right, so let's take a look at, now remember processing is Java based, and so we have to then have this import statement here. Import processing.serial.asterisk. The dot asterisk says to import all the libraries, all the processing serial libraries. We need to then create, so these are global variables. We're going to create an object of type serial, right? It's named myPort. We're going to then create a font object because we're going to show some font in the, we're going to create a font and use that for the text in the window. This data type string is going to be a character array, right? And then this integer variable LF here is an ASCII line feeder, the new line character. All right. Let's take a look at what's going on in setup, right? So we're creating, then he's creating a window that's 400 pixels wide by 200 pixels tall. And he's going to then load this font into the program. Well, so this note that says you'll need to make this font with a create tool font. Here then is the name of the font. I'm going to copy that. You go to tools and go to create font, right? It pops up this window. Right, it defaults to some font here. The size, if I want the size 18 that he's using, here I can do that. And this will show me then all the fonts that are available. If this one is not available, sorry, here, I could copy this in and say OK. And that should load the font in if it exists. If it doesn't exist, we might have to go pick another. Right. So text font, my font, calling this function then to create, to construct this font object here, then with this size. Here's an important thing for working with the serial port. This function called print array, we're going to pass to it serial.list, and it's going to list all the available ports on the system, right? For everything that is connected to it. And then his note is, he says he knows that the first port in his serial list on the map where he wrote this is always this adapter, so he opens that port. Well, let's then display our list. I'll display my list and we'll take a look at what this is choosing. So let's see if I can just go ahead and run. All right. So I get this window popping up with null. We're going to ignore that now, right? This is the window where we're going to write text. But what I want to pay attention to here is this right here. Print array serial.list generated this list right here. So notice then, really don't think I can make that list any bigger in the console display, right? So see this in brackets, that's an index, right? If you know arrays, this is index location 0. So the first string in the list is COM4. The second string in the list is COM7. So the index 1, index 2 is the third string in the list, COM8. So right here, where he's creating this object. So in Java, to then create this new object, we use new serial. We pass it to this pointer. This is okay if you don't understand Java classes and Java objects. Just know you need to do this then anytime you want to connect to the serial port. We call new serial, pass it to this pointer, comma, serial.list. What that does is it generates the same list that printed out down here. But this right here, this says go ahead and grab the first thing in the list. Now, if your system, if you were on COM7, say here I wanted to connect to COM7, I would change this to 1 because this is index location 1. If I wanted to connect to COM8, which is index location 2 on my system. I changed that to 2. Now, my particular system right now, my Arduino is on COM4, so I want to leave this at 0. Right? And so this then will connect to the right COM port, and then this is the baud rate, 9600. And my Arduino program is going to be set up with a baud rate of 9600. I want it to match here, because what the Arduino program is going to do is it's going to transmit to processing, and processing is going to receive. So we're setting up the serial port. In this case, we just have to create this object and basically open up this functionality on this end. Right? The list is what generated the list down here, which helps us determine what this should be here. Right? Now this command, myPort.bufferUntil, well, when it reads information in, so when this processing is reading information that's coming into the serial connection, buffer_until means it's going to store that. A buffer is an array. It's going to store all of those characters and keep storing them until it reads this character, which is that line feed. So from the Arduino side, when we're ending some data, signaling end of data transmission, we're going to append that new line character on, so that over on this side, it'll keep reading and storing until it gets to that new line character. Right, so that's what we do in setup. We create the window size. We needed to load the font, right? Constructed here with this call the text font. We print out our list that helps us to see what's available. We have to do this to open the port. And then we set up this myPort.bufferUntil that says go ahead and keep reading and saving information, keep receiving and saving until you get this line feed character. What the draw function is doing, background 0. So remember 0 is black. So in this window, it's then drawing a black background, and then it calls this text function. And this text then is printing out received : space. That's why you see received. Notice it's not actually using the Arial font. It didn't recognize our font in this case. We can change that in a second. It's printing out received space. And the reason it's printing out null is it's trying to print out what's stored in string. Well, in-string doesn't have any information in it. Notice it was declared here, but we didn't store anything in it. So by default in Java, that is equal to null. And that's why you're seeing null print out up here. And then this text function says, well, where do you want to print in the window? Well, this is column 10, row 50. You can change those things for where you want to print it. Right. The font size then was determined by the font that we loaded up here. And so when we write our Arduino program and start transmitting, what we'll do is we'll transmit some numbers, and we'll see those numbers popping up here. Right. So what the serial.event function is doing is nowhere in this program do we ever directly call serial.event. Serial.event is one of those functions in Java that whenever an event of this type has occurred, this function will be called. So the way this works is that in processing, we're going to keep looping through this draw function. Remember, this draw is an infinite loop. Remember that setup occurs once at the start of the program, right? When it's done, it goes into the draw function, and this is an infinite loop. Well, what happens is draw runs this command, then it runs this command, and when it gets to the end of this function, it says, have any events occurred, right? And if a serial event has occurred, then it will automatically go to the serial event function and run the code that's in here. Now we have to code this just like this, right? Void, the name has to be serial event, and you have to have this one argument here of type serial. Here the port is being referred to as P because that's the name of the identifier, the parameter in this list. So this is calling p.readString and storing this in the global variable inString. If we take a look at, so if I go back over here to processing, let's go back then to I'm going to go back one screen here. So let's take a look at readString. What readString does is then it just interprets all the information in the buffer as a string, and it's going to store it in our variable. Right. So here it returns all the data from the buffer as a string. It assumes all the incoming characters are ASCII. Right? If you want to work with Unicode, we won't be doing that. We have to follow these instructions. But it's just going to return a string type, which is why here we declared this globally as a string type. So we'll see that inString then has whatever value we read and store in it, and that will be printed out on the screen when this executes. Right. Now let's go ahead and perhaps choose a different font because this one didn't exist. I can go to Tool, actually let me stop this. So Tools, Create Font. Right. I still want to stick with 18. Right, you can pick on these. You can pick these different fonts. Right, to see what you get. All right, I'll just happen to pick that one. I'm going to copy this. I'm going to say Control C. I'll say OK here. I'll replace that. I need to keep the .vlw here, and I'll replace it with this. Now when I run, I get a different font up here, right? We're still getting null. We're still getting null because from the Arduino side, we need to write a sketch that needs to transmit. This is the receiver. This is the serial receiver. Let's now write our transmitter. All right, so this is just a blank Arduino sketch. All right, I'm just going to create an unsigned char. I'm just going to call this value. I'm going to initialize value to 0. I could have done that up here globally. I did it in setup. We're going to use the serial port to transmit, so we're going to set the serial port up at 9600 baud. Remember our processing sketch then on that side is also set up at 9600 baud. And now let's just go ahead and transmit, right, the transmit value once per second. Right. So if I just say serial.println, right, and write value, and let me upload this to my Arduino. I'm going to save that as serial.transmit count. All right. Now I wanted to double check that I didn't have processing running. If I have processing running and tying up the port, this won't upload. Right? This has uploaded. What I can do is I can just check here. I can open the serial monitor and notice, okay, I'm getting lots of values of 0. I said once a second, but did I actually put the delay in? No, I did not. All right. All right. Let me re-upload that. So a lot of times then, before I send things to processing, since this is transmitting, I know I can just open the serial monitor and see what values are being transmitted. And you can see we're transmitting just the value of 0 once a second. I need to close this because if I want processing to be able to grab the port, I can't have the serial monitor as the receiver. One or the other, not both. So now, if we just go ahead and say run here, all right, notice now we're just getting the value of 0 here. Sometimes you get this message in processing, no glyph found for this particular character. Don't worry about it as long as your text is displaying correctly. There's nothing we can really do about that there. All right, everything will be okay. All right, now that's not really exciting because we just see the value of 0. But now we know that we've transmitted some information from Arduino to processing. All right, let's just go back here and let's just change this to twice a second. And let's go ahead and then as well, let's increment then value equals value plus 1. Right here, good, 0, 1, 2, 3, that's what I expect. I close this down. I'm going to tell processing to run now. Right, so now we get 0, 1, 2, 3. Notice we're getting that update. So now processing is receiving this information. Right, it's running the background function, it's printing out text and what it receives, and then if there's been a serial event. Right? A serial event then is triggered by the fact that we're buffering this information in the background. It's receiving this simply because we connected this port to the same line, right? The same port as Arduino. Arduino is transmitting. This is receiving. It's buffering until it gets a line feed character. Right? Let me stop this. What happens here if I made this Println? What happens if I just make this print? So let me upload that to Arduino. Right, if we run this, we're going to see, right, we get 0, 1, 2, 3, 4, 5, 6, right, 7, 8, 9, 10, all on the same line. Right, we're not transmitting a new line character. Will processing still work? No, it won't. Right, we keep getting this value of null because we have this buffer until line feed. Notice then the serial event function is not being triggered because it's not getting the line feed. So it's very important then that we transmit with ln over here that line feed character in order for processing to work. Right. So here, right, we can see this rolling over. Right, now let me pop back open this reference. Right, when we were taking a look at this int string, notice here this was declaring this locally here, and it was just printing information to the console window. That's what Println does. And notice it was only printing in the cases where this was not equal to null. Right, so we could add some code like that as well. Over here, then in processing, I'll just stop this from running, and let's add in here. Let's just go ahead and write in string to the console. All right, we do that with Println, so that says print to the console, add the new line character to it, in string. So if we do that, and let's just do that if in string is not equal to null. Right, so we get the null showing up there. Eventually now notice, right, there appears to be a blank line in between these. Well, by using Println here, in string contains that new line character. Right, there's actually a trim function that we can use to get rid of the new line character if we wanted to from our string. And let's see if there's a reference to trim here. So what the trim function does is it removes white space characters from the beginning and end of a string. Right? In addition to standard white space characters such as space, carriage, return, and tab, this function also removes the Unicode character. Well, we're not working with Unicode, so we don't have to worry about that. So if we wanted to remove the string, right, we can say remove white space characters from string. And we can simply say now in string is equal to trim. We're going to pass in string to the trim function and then store it back in here. So notice then when trim is used, right, we call the trim function, we pass it then that string, it's going to return. So notice it returns a string or a special string array. Right? And now this will get rid of the white space character. So if we stop and now we rerun that, notice then we don't have that extra white space character here anymore. Right? And now we have our numeric digits. And there are ways that you can convert that string to a numeric digit. In our case, right now, we're just showing this to the screen. But you could then create a variable something like float fl is equal to, and I can pass this in string, and now I can then print out, now I'm going to print out in string, so we can see what that is. These really aren't going to look much different. One's going to be characters, so I want to print out this string. I'm going to append in string to it. So Java libraries have a lot of nice string functionality. I can print out the string, I can append a variable to it, which it will turn into a string for print. Then on a separate line, let's just show what fl is, right? I'm going to append to that fl, if I can type. All right. And notice now, right, we've got these is a floating point number, it's appending, right? It's appending 0.0 to it simply because these are integer strings. But we're able to then convert that to some sort of number that we can work with. Right, we could take this value if we wanted to, and we could start controlling. Now this is local, so let me make fl global so I don't have to pass it. Float fl. Now, in processing, if we don't initialize a number to something, it will be initialized to 0, so that step was redundant. So here I don't want to redeclare it, I want to use the global. And now I can say, draw a circle with with diameter fl. Right. And so to draw a circle, let me just give it some bright red fill color so we can see that here. And I'm going to make the center of this the center of the window. So width divided by 2, height divided by 2. Right. And then the diameter is going to be fl. What we should see is as our number gets bigger, we should see then this diameter of the circle getting larger and larger. Now, and I need to see that tiny circle, watch that getting bigger and bigger and bigger. All right. Let me then, notice how that changed the color of my text. So if I want to leave then the text is white, right? We're going to say white text. Red filled circle. And right, I can even change the background if we want to see the stroke color. Actually, no, let me leave the background black. So our circle is really tiny. Notice as this is getting bigger, right? The diameter is getting bigger and bigger. Right, so now we can control things in here based on information we get through the serial port. That was the gist of this, right? What you should do is create, I always go back to the processing reference if I'm connected to the internet. If not, then I pull up some old code where I was working with receiving information as well, and use that then to recreate this, right? Because it's a little hard to remember all these steps unless you write this code on a daily basis. So always use a good example then to get your serial port and serial event set up correctly. I always write some sort of test program from Arduino just to make sure that things are being received, transmitted and received correctly before I start connecting that to hardware. Right. That was the end then of this lesson on how to send information from Arduino and receive it with processing.